Okay, welcome back to Teen Stop Natch Academy. We're looking at this differentiation today, particularly implicit differentiation. So we're given this particular problem to solve, and this says if s squared plus y squared minus 2s minus 6y plus 5 equals to 0, find the y over the s. Also asks us to find the second derivative of this particular function or equation at s equals to 3 and y equals to what? 2. So just make sure you follow along with me as I'm going to solve this problem. So you can apply this method to solve similar problems that you may have. So, but if you still have another question that you would like to ask me, then drop it in the comment section. Okay, let's go ahead to solve. Can I say solution? So we are given this s squared plus y squared minus 2s minus 6y plus 5 equals what? 0. This is what I was given. Then, so if you are differentiating now, you need to look at what question that is given to you. And here, we'll first solve this before we go to the second derivative. And they say we should find the derivative of y with respect to that of s. So now you can come back to this place and say, okay, we have s here, we have y here. So we're solving for y with respect to s and not s with respect to y. So in this case here now, if you are solving y with respect to s, you are going to have 2s as your answer. Then plus here, we're solving with not y, we're solving s with respect to y. So there's no x here. If had it been it was sy, would have solved and we'll get y. So in this case now, we're going to write 2y dy over what? Dx, showing that there's no s there. So it's not with respect to what? Y, but with respect to x. So the next one, we're going to solve this and we'll have 2 as the derivative. Then we come to this, we're going to have minus what? 6, because we have minus 6y. So this will be 1 over 1. So we remain minus 6. And this is y and not s. So you add the y over what? The s. Then plus this is 0 equals to what? 0. All right. So when you differentiate a constant, it's 0. Next thing is you have 2x plus 2y dy over what? Dx minus 2 minus 6 dy over dx is equals to 0. Then, having reached this point, what you now do is to group them together, those ones that are like. So now you have this and this, we have this and this. So you are going to write 2s minus 2, then coming together plus, then this is what? 2y dy over dx minus 6 dy over dx equals to 0. That implies that this should be 2x minus 2, all right? Then plus, then this and this should be 2y minus 6, okay? Then I have dy over dx in common, which is equals to what? 0. Now, take these two to the other side of the equation, and when it crosses, remember, it's going to be a minus, and the signs here will change. So we are going to have 2y minus 6, all right? Then dy over dx is equals to, so if this crosses, it becomes minus bracket what? 2x minus what? 2. I hope you are following along. So next one. We have this 2y minus 6 dy over dx is equals to, so this clearing, we are going to have minus 2x plus what? 2. Okay, so now we are going to have this, divide both sides by this, we are going to have dy over the x is going to give us 2 minus 2x all over what? 2y minus 6. So the y over the x is going to give us, factor out what they have in common. We have 2 in common, remaining 1 minus x all over. They have 2 in common here, 2, remaining y minus 3. So this can go against this. So can I have that the y over the x is equal to 1 minus s all over y minus 3. So this is the derivative of y with respect to s based on the given question. So now they say at s equals to 3, y equals to 2. So you need to substitute the values of y and that of s in the above answer, which is the derivative. So now you have the y over the s is equal to 1 minus 3 all over what? 2 minus 3, which is going to give us minus 2 all over what? Minus 1, which is going to give us what? 2. Therefore, we cannot say that the y over the x is equal to what? The y over the x is equal to 2. Then the y over the x at what? 3, 2 is equals to what? Equals to 2. Okay, this is what? 1 minus x all over y minus what? 3. So let's keep that as we go ahead to solve the second one. So the next one says we need to find the second derivative of this particular problem, and at s equals to 3 and y equals to 2. So what you need to do there is now say the square y over the l squared, okay, is now equals to d of what? Over the x of what? Then 1 minus s all over what? Y minus 3. So we are going to find the derivative of this. So finding the second derivative is like when you've already gotten your first derivative, then you need to differentiate that first derivative again in order to get the second derivative. And that's what we're going to do. This is the first derivative we got. So we need to differentiate this first derivative for us to get second derivative. And here, if you have to find the third derivative, that means you need to do 3 times, meaning you need to differentiate the first to get the first derivative. Then you need to also differentiate this first derivative to get the second derivative, and that also you need to differentiate the second derivative in order for you to get the third derivative. And here, that's what we're going to do now, differentiating the first derivative to get the second derivative, and because that is what they asked us to do. So now we need to apply this quotient rule because it involves division sign. So we now recall that quotient rule states dy over the x is equal to v du over the x minus u dv over the x all over v squared. So in this case now, we can say this should be u and this should be what? V. Means the numerator is u and the denominator is what? V. If that happens, so we now say that u is equal to what? 1 minus x. Therefore, the u over the x is going to give us, if you differentiate 1, it's going to be 0. If you differentiate minus s, it's going to give us what? Minus 1. Now, coming to v, while v is equal to y minus 3, then the y minus, that is the v over the s is going to give us, differentiating this, all right, if you differentiate y with respect to s, it's going to give you something that, because we are not differentiating with respect to y. So in this case, if you differentiate y, you are going to have 1. So it's going to be what? 1 dy over what? dx. Differentiating this is going to give us 0. So 1 multiply dy dy, so it's the same as what? Dy dx. That's what you're going to have. So now, we need to substitute the values of this in this particular question. So please permit me to use this side. Okay. We have the y over the f is equals to v. V is what? Y minus 3. And I say y minus 3. Then bracket du ds is minus 1. Then minus. Then the next one is v u, which is what? 1 minus x. The v du ds is this, which is what? Dy over df. Okay. Next thing there, we now say divide by v squared. V squared, our v is y minus 3, or what? Squared. Okay. So that's how you solve that. Now, if you are looking at this now, you need to clear something, which means this minus will come to multiply. And if this multiply this, you're going to have minus y, then you have plus 3. So it's going to be the y over the f is going to be what? 3 minus what? Y. Okay, that's for this side. And this side, you're going to use this minus to multiply, and you're going to have also minus, okay, let's leave it, minus y minus what? S, the y over the s, then divided by what? Y minus 3, or squared. So now you can, sorry, this is the squared. So now you can now solve this. At s equals to 3, y equals to what? 2. So what are we going to have? We have this squared, y over ds squared equals to 3 minus, then y is what? 2. You can say 2 minus bracket 1 minus 3. Then the y over the s, remember we got the y over the s at this to be what? 2. So because we are treating this now at 3 and what? 2. So that is why you are using this, and you got it to be 2. You can say 2 divided by, then y is what? 2 minus, then 3, all squared. Okay, that's how you solve this. So having the y, the second derivative, at 3 and 2 is going to give us 3 minus 2 is what? 1 minus, then 1 minus 2 minus 3 is what? Minus 2, then multiply by 2, or divide by 2 minus 3 is minus 1, then all squared. So the second derivative will now give us at 3 and 2 is going to give us 1 minus, this is going to give us 1 plus 1 plus this multiplied by this is going to give us minus minus 4 all divided by what? 1. All right, because minus 1 times minus 1 is 1. So in this case, if you multiply this by this, you're going to have minus 4. Then they see minus sign here. So it means that the squared y over the s squared, then at 3 and 2 is equals to what? Minus multiplied minus is plus, then this is going to give us 5. All right, so at s equals to 3 and y equals to 2, for first derivative we got 2, then for second derivative we got what? 5. All right, so that's how you solve. Then the normal equation that we got for first and second derivative, so we got this for first derivative, sorry, second derivative, and we got this for what? First derivative. So this is how you solve this kind of problem. All right, please, if you've not subscribed to my channel, make sure you do well to subscribe. All right, then share to others, maybe schools, for them to learn how to apply this implicit function of differentiation. Thank you.